Okay, as I said, we got a couple problems up here for you to try quick. Give you a couple minutes to work on those, and then we'll go over them. So let's just take a look at how you're doing on this. So this first one here, where are we going to start? Dividing. $34 goes into 51. So the 0 is the last digit we use, so put the 1 there. Then what? Subtract the 34 from the 50, yep. Gives us 16, okay? Bring down the 0, yep. 34 goes into that 4 times. We put it above the 0 because it's the last digit we used. Careful. 136, right? There we go. Then what? Sure. Then what?
Subtract it.
Get 24.
Bring down the 4.
Bring down the 4.
7 times.
7 times. Now the 4 is the last digit we use, so the 7 goes above the 4. 238. Then what? Subtract it to get 6. Bring down the 8. And then twice. That is 68. There's 0 left. All done. So 50,048 divided by 34 is 1,472. How about over here? What are we going to do?
Start multiplying the top number by 9.
So 9 times 3 is, so 7, carry the 2, yep. 9 times 6?
54.
54, so put down a 4? No, what do I got to do? We got to put in a 2 there, so 54 plus 2 is 56. 6, carry the 5. 9 times 2? 18, but we have to add the 3, or the 5 to make it 23. 3, and we carry over the 2. Now what? Put our 0 in here. Move over to the 4. Now I also do this. I usually put a line up there because that helps me separate what I already carried with what I might carry new this time around. 4 times 3 is 12, so 2, carry the 1. 4 times 6? 24 plus 1 is 25, so 5, carry the 2. 4 times 2? 8 plus 2 is 10, so 0 and carry the 1. And then add 7, 8, 8, 2, and 1. 12,887. Anybody have both of those right before I did them? A few of you? Cool. Anybody have absolutely no idea how to do that? Wants me to go over some more examples?
No, one more.
What's that?
One more.
Which one? Multiplication or division?
Multiplication.
Multiplication? Okay. Let's look at this one. Talk me through what to do on it. 8 times 2 is 16, so 6, carry the 1. 40, yep. Plus 1 is 41. 1, carry the 4. Perfect. 8 times 3 is 24, plus the 4 is 28. So 8, carry over the 2. Put the 0. 4 times 2 is 8. 4 times 5 is 20. 0, carry 2. 4 times 3 plus 2 is 14, so 4, carry the 1. And then 6, 9, 8, 6, 1. Okay. Well, our new topic for our second hour class today deals with defining the size, the magnitude. We've talked a little bit about working with the names, but the count portion of a number. Now you might think, well, why do we need to define that? Because it's pretty obvious. 3 is 1, 2, 3. But there are times where we have to have more of a formal definition to work with them. So what does it mean for a number to be 6, to have a count of 6? Well, we come back to our number line again. Six is represented on the number line with what we call a vector. You don't necessarily need to know that word, you just need to understand what it means and how it's used. A vector is just a really fancy word for an arrow. The arrow starts at 0 and goes to the value indicated. So the vector for 6 starts at 0 and it goes to 6. That's the vector for 6. Now, one of the reasons why it's so important to define these values, these numerals or whatever like this, is because we run into things like this. -4. And to work with that, we need to have these magnitudes defined. So -4 would start at 0 and go to -4. Now, if we want to compare that to a +4, like this, if I'd drawn my line here to scale, what you would see is their lengths are pretty much the same. They should be exactly the same. They just point in opposite directions. So 4 and -4 have the same length, they just go in opposite directions. Now that we've defined the amounts or the magnitudes, let's look at our most basic operation of addition. The definition of addition is to combine the vectors. 6 plus 4 is telling us take the vector for 6 and the vector for 4 and combine them. Well, the red one is the vector for 6. This green one is the vector for 4. If I combine them, I end up at 10. 6 plus 4 is 10. That is the definition of addition. So with that definition out there, I should now be able to throw in some negative numbers and it should work just fine. Let's try 6 plus a -4. Now your textbook will usually do this. Puts parentheses around the -4 just to separate it out. When we talk about order of operations, the parentheses are telling us to do something first usually. In this case, they're not. They're just separating out that -4, so we know it's a -4, not -4. So now the vector for the 6 is the red one. The blue here is the -4. Oops. There we go. If I put those together, I end up at 2, if I drew them right. Yeah. Close enough, yes. No, I'm not saying every time we work with negatives, with integers they're called. Integers is the proper term for negatives mixed in with our positives. We don't have to draw out the number line. But I do keep this picture in the back of my head when I work with integers. If I have 7 plus a -12. Here's 0. 7 goes in the positive direction. Now 12 is negative, so it goes the opposite direction. Is it longer or shorter?
Longer.
It's longer because 12 is bigger than 7. So we know it goes past 0 and it goes into the negatives. So the answer here, we know 2 things about it from the picture. One is that the answer is going to be negative. 2, it's the difference in length between 12 and 7. Well, what's the difference in length between 12 and 7? 12 minus 7 is 5. Or I might have -8 plus 11. So my picture is going to be, here's 0. Which way does -8 go? To the left, negative. Does 11 go the same direction or the opposite direction? Opposite. Longer or shorter? It's longer, so it goes past 0. So that tells me that answer is going to be on the positive side, and it's the difference in length between 11 and 8, which is 3. So you have more complicated problems like this. Something like that. So again, I don't have to draw it up to scale. I just say, here's my 0. 238 goes this way. Negative 125 goes the other way, longer or shorter? Shorter. So I know it doesn't get back to 0. So I know my answer here is still positive, and it's still but they go opposite directions, so it's still the difference between 238 and 125. So I may actually have to do subtraction. 113. So it's a positive 113 is my answer. What do you think? Not so bad? Better than a sharp stick in the eye?
Mm-hmm.
Okay. Give me some time. That might be questionable before the semester's over. I want you guys to try this one. Tell me what that one's going to be. Very good. Did everybody see how that works? Yeah, here's our 0. Negative 49 goes this way. Negative 128 goes the same direction. So that tells us two things. One, our answer is going to be negative. It's on the negative side of 0. 2, the size of the magnitude is just 49 plus 128. 177, because they go in the same direction. They build on top of each other. They add together in their length. Does that make sense? Mm-hmm. Okay, well, then on to the next step. Subtraction. You got it. Let's look at 8 minus 3. Let's put this on a number line. Bless you. Eight minus 3, if we were to draw this out, I'd imagine the picture would look something like this. There's 8 minus 3 brings us back to 5. If we look at this picture, though, these vectors remind us a whole lot of 8 plus a negative 3. In fact, that is the vectors for 8 plus a negative 3. The reason why, one of you brought it up earlier, this really means this. This symbol here, that we've always known as the subtraction symbol, means, it's a form of addition, it means add the opposite. So when we're subtracting 3, what we're really doing is we're adding the opposite of 3. The opposite of 3 is negative 3. Yep.
If you scroll up, because basically what you're doing is changing the middle to an add and then making whatever it is the opposite.
Yep.
So theoretically that 149 would be, you change what you're adding.
That's there's no operation in front of that, so you don't change that.
Okay.
That negative is with the 49. We change this because there's a subtraction here.
If it was subtraction, then it would have been a positive number.
Yes. So let's do negative 7 minus 3. What's that mean? Well, it means negative 7 plus a negative 3. Well, we know that's negative 7, negative 3, which is going to be negative 10. Nine minus 4 becomes 9 plus a negative 4. Positive 9, negative 4, it's going to be positive 5, or just 5. We don't have to put the positive in front of it. Here's the one that most people struggle with. Seven minus a negative 8. It's going to become 7 plus what? 8, yeah, plus the opposite of 8, or negative 8, would be positive 8. So this is 15. Good. Let's try this one. What's this one going to become? Negative 9 plus a positive 6, otherwise known as negative 9, positive 6 is going to be at negative 3. What do you guys think? I want you guys to try a few of these, and then we're going to talk about multiplication just a little bit. I want you to try 11 through... Yeah, we're not going to go quite that far. Let's try like 11 through 39 for now. You're not going to get all those done. I'm just going to give you a few minutes to make sure you've got them down. And then on page 114, I'm going to have you do 1 through, let's go 35 for now. Again, just do the odds. I'm going to let you work on those for a few minutes. While you're working, I'm going to actually pass out the packet with the answers for the odd number problems so you can check your homework. Just the odds on both of those, yep. Anybody have any questions on those that they've been able to get to so far? Anything not working out? Or... The negatives are definitely a different way of thinking because they're not a natural way of thinking about numbers. We're so used to thinking of everything in terms of positive and subtracting rather than working with the negatives. So anyway, the next step, we want to look at multiplication. Now, as we mentioned before, when we first learned to multiply, 5 times 3 was repeated addition. 5 plus 5 plus 5 gives us 15. So then from there, it's not that big of a step to think of negative 5 times 3 is just going to be negative 5 plus negative 5 plus negative 5. Not such a big deal. Negative 15. Negative 5 plus negative 5 plus negative 5. Negative 15. And even from there, it's not too big of a stretch if you're doing 5 times a negative 3. Now, this is saying, what this is really telling us to do is take 5 and add it together negative 3 times. We can't do that. But what we can do is switch the problem. When we're strictly multiplying, we can switch the order of the two numbers and do negative 3 times 5, which is then going to be negative 3 plus negative 3, of course 5 of them, plus another negative 3, plus another negative 3, plus one more negative 3, which is going to be negative 15. The 15 seems to be a common theme here, right? Because we're dealing with 3s and 5s. The one that's the stumper is if we have negative 5 times a negative 3. Now we've been taught that has to be what? A negative times a negative is positive. That has to be a positive 15. The question comes out as why? We cannot take negative 5 and add it together negative 3 times. We can't do it. We can't switch it around and take a negative 3 and add it together negative 5 times. The definition of multiplication here breaks down. It does not work. There are actually several times in math that we run into that, where our definition doesn't work. So what we have to do is look for a pattern and define the answer to be whatever makes that pattern true or makes the pattern continue. So we said negative 5 times 3 is a negative 15. So let's continue this pattern. What's negative 5 times 2? Negative 10. Negative 5 times 1, negative 5. So now we try to find the pattern. When we start with negative 5, if we decrease the number we're multiplying by 1, from 3 to 2 we were decreasing by 1, from 2 to 1 we're decreasing by 1. What happens to our result?
Decreased by 5.
Not decrease, but increases by 5, from negative 15 up to negative 10. From negative 10 up to a positive 5. So if we keep going here, negative 5, what would we have to put here to continue this part of the pattern? 0. 1 minus 1 is 0. What would have to go over here to continue this part of the pattern? Yeah, negative 5 plus 5 is 0. Is that true?
Yeah.
Yeah, so that pattern appears to be a true pattern. So we're going to assume that it continues. So negative 5 next would be negative 1 here. What would be next over here? Positive 5. Next here would be a negative 2. What would be next over here? Positive 10. This would be a negative 3. What's going to be over here? Positive 15. The one and only reason why a negative times a negative equals a positive is because it continues the pattern. Because technically you cannot multiply two negatives. The definition of multiplication doesn't allow it. So we defined the product of two negatives to be a positive number because it fits our pattern. So if I have negative 8 times a negative 2, I'm going to get positive 16. Negative 7 times 4, I'm going to get negative 28. 9 times a negative 3, I'm going to get negative 27. Negative 4 times a negative 5, I'm going to get positive 20. Perfect. The moral of the story, as you can see, when I'm multiplying, if I have one negative and one positive, the answer will be negative. If I have both negative or both positive, the answer will be positive. Now that is when I'm multiplying. Don't confuse that with addition and subtraction. Addition and subtraction, we have to go back to those vectors again. It's only when we're multiplying that two negatives make a positive, and so on. Now for division, remember division is defined to be the reverse of multiplication. So if I have negative 16 divided by 2, what that is actually asking me is what number times 2 equals a negative 16? Well, first of all, does this have to be positive or negative? It has to be a negative, because a negative times a positive equals a negative. What number times 2 is 16? 8. So that has to be a negative 8. So negative 16 divided by 2 has to be a negative 8. 21 divided by a negative 7. Always go with negative 3, apparently, since I wrote it down wrong. That is asking us what number times a negative 3 equals 21. Well, first of all, does this number have to be positive or negative? Negative, because a negative times a negative gives us a positive. What times 3 gives us 21? 7. So this would be a negative 7. If I have a negative 32 divided by a negative 8, again, that is asking me what number times a negative 8 is going to give me negative 32. But what does this have to be, positive or negative? Positive. And what times 8 is 32? Positive 4. So this is a positive 4. So we can see with our division that same pattern holds up. If I divide a negative by a positive or a positive by a negative, I get an answer that's negative. If I divide two negatives, I get an answer that is positive. So just like with multiplication, if I have one positive and one negative, my answer comes out to be negative. If I have both positive or both negative, the answer comes out to be positive. So to add to the homework that you've been working on, I'm going to expand these from 11, obviously those 11 through 39, I'll just keep it there, odds. And 11 through 35, the odds, I'll keep those there. On page 116, I'm going to add to it 1 through 39, the odds. So you have about 12 or 13 minutes here. I'll give you a little bit of time to get started, and then we'll go over a couple just to make sure you're doing okay. Okay, so we have a negative 3 minus a negative 9, right? So the negative 3 doesn't change. That first number never changes. It's the one we're subtracting, so it becomes plus the opposite. What's the opposite of negative 9? Positive 9. So now from here, we have to use the vectors. Negative 3, if we start at 0, goes to the negative side. So that looks like 0. 9 goes the opposite direction, and it's longer, so it goes past 0 into the positive side. So the answer is going to be positive, and it's the difference between 9 and 3, which is 6. It's a positive 6. That's the key, is every time you see subtraction, you've got to say add the opposite. So since this is subtracting a negative, it becomes adding a positive. Yeah. I mean, there are some little gimmicks like that that are okay.
So 12 minus negative 6 is going to be a positive number.
Yeah, 12 minus a negative 6. That'll become 12 plus positive 6. What if I have negative 14 minus 7? What's that become? Does the negative 14 change? No. This becomes plus a negative 7. So here's from 0, negative 14, negative 7. They go the same direction. Negative 1.
So how does it become a negative 7?
Because subtracting a 7 means add the opposite of 7. So when we change this from subtraction to addition, this has to go from positive to negative. Basically, you can't change this part without changing this part. Any other questions?